In 7.3, we are going to talk about the trig functions on the unit circle. In part 1, we are going to talk about finding the trig functions for any angle, and then in part 2, we are going to be more specific for those angles on something called the unit circle. So let's start with part 1. So let's say we have the x and y axis, and we have built a triangle based upon some point xy, and you always build this by connecting to the x-axis and connecting to the origin. You'll see me do that every time. Your x and your y are just directional based upon where you're at. They could be positive or negative. If they are here, remember that's quadrant 1, so they are going to be positive, positive. Here's quadrant 2, they will be negative, positive. Quadrant 3, they'll be negative, negative. And in quadrant 4, they're going to be positive, negative. So for the first time, we might get a side of a triangle, which we will reference as positive or negative. Now, the hypotenuse of our triangle, because we have built it out of this point xy, will always be the square root of x squared plus y squared. Now, that is because of the Pythagorean theorem, so we can always expect that to happen. So let's take a look at what we see here. The cosine is always x over r. The sine is always y over r. There we go. And the tangent is always y over x. Now, I've just started with the x and y, so it kind of went in that xy order, but you can just as easily switch it around based upon the way we usually write those things. But it's just adjacent over hypotenuse is our cosine, opposite over hypotenuse is our sine, so it's not really anything new, except now we can label them x's and y's. So then our secant is the flip of the cosine still, our cosecant is the flip of the sine still, and our cotangent is the flip of the tangent. Now, theta will always be this angle closest to the origin inside of our triangle. We're going to call that a reference angle in most cases, but we want to put that angle inside of our triangle closest to the origin and the x-axis. So let's do an example using that very information. It says, let the point negative 4, 3 be a point on the terminal side of an angle theta in standard position. Find the exact values of the 6 trig functions. So when they say exact values, they want us to use what we know about the sides of a right triangle. So we need to build this. So we're going to go 4 to the left and 3 up. We're going to put that point down. Just like always, that point lands where that point lands. Now, the next thing I want you to do always is connect that point to the origin, connect that point to the right, to make a right triangle, connect that point to the x-axis. Label how many you went in the x direction, label how many you went to the y direction, and always put your theta next to the origin. So now we've built that triangle, so the next thing I want you to do is to find the hypotenuse. Now, the hypotenuse is always going to be the square root of x squared plus y squared. The hypotenuse, unlike the legs, the x and the y, the hypotenuse will always be positive. The x or y may be negative depending on the direction of your point. So we get 16 plus 9, or the square root of 25, so our r is 5. Now that we know that, please note that our adjacent is always going to be our x, the opposite is always going to be our y, and the radius or the r is always going to be our hypotenuse. So just do what we did before, sine, cosine, and tangent. The sine is always going to be opposite over hypotenuse, or y over r. So that is always going to be 3 over 5. The cosine is always going to be x over r, or adjacent over hypotenuse. And you'll notice for the first time we got a negative value. And then our tangent is always y over x, and we're opposite over adjacent. In this case would be 3 over negative 4, or you could write that as negative 3/4. Now that we have those, now we need to move on and find the other 3 trig functions. So I'm going to write the appropriate reciprocal next to it. So this is cosecant, secant, and cotangent. So just flip over those fractions. So this would be r over y, or 5/3. This would be r over x, or 5/4, negative 5/4. And this would be x over y, or negative 4/3. So that is how you find the 6 trig functions, their exact value for an angle theta that is created from a certain point on the terminal side of our angle. Now let's do another one. At this point is the point -3, -6. So we find our point, we can label it. So that would get us into our third quadrant. We're going to connect it to the origin, connect it to the x-axis to form a right angle. Theta always goes by the origin. Let's put on our side, -3 here, -6 there. Let's find our hypotenuse. It's always going to be -3 squared plus -6 squared, the square root of x squared plus y squared, or 9 plus 36, or the square root of 47. If I could add right, how about the square root of 45? Now, we can't do much with that, but since 9 times 5 is 45, that would be 3 radical 5, and that's what I want, the simplified version. But this word exact values means don't put that into the calculator. Simplify it as far as you can and stop. So let's find the 3 originals, sine, cosine, and tangent. Now, sine will always be opposite over hypotenuse, or y over r. So let's set that one up. So the y value was -6. The r value was 3 radical 5. I'm going to leave it like that for a moment, but you can reduce it. The top and bottom are both divisible by 3. The 5 is its own animal. We have to rationalize, pop the radical to the top. It will sit next to the 2 and leave a normal 5 behind. Okay? Cosine is adjacent over hypotenuse, which reduces down, which needs rationalized. And then finally, tangent is y over x, or -6 over -3, or opposite over adjacent. You can think of it in any of those ways, which reduces down to 2, or 2 over 1. Okay. Now let's talk about our 3 trig functions that are reciprocals. So I'm going to put cosecant next to this one, secant next to that one, and cotangent next to that one. Now you can flip over any version that you want. Here, I think this is probably the best to flip, because that'll just bring that square root up to the top, and I'll throw the negative out in front. I'm going to flip this one. So I'm just going to get negative square root of 5 over 1, which is just negative square root of 5. And this one I will flip 2 over 1, which is 1/2. So that is how we find an angle that has landed us at a certain spot on the xy axis. So they're really talking about the angle that got us to there. So that is the sine, the cosine, and tangent of the angle that got us there. Now we're going to do one last one, and then we'll talk about the homework. It says, let the tangent be equal to 5 over 12, and the sign is negative. Now let's do a little bit of contemplating here. For the sign to be negative, the sign is y over r. The y's get negative down here. So we are either in quadrant 3 or quadrant 4. So that's what that tells us. That just says, hey, we're either in quadrant 3 or quadrant 4. Now, the tangent is a positive, 5/12 in this case, but the tangent is positive when the x over y are the same sign, or sine over cosine is the same sign, or opposite over adjacent is the same sign. All of those things happen, and that only happens here and here. So that happens in quadrant 1 or quadrant 3. Well, those things have in common, it must, for them both to be true, it must happen in quadrant 3. So let's build a triangle. Now remember, tangent is y over x. And we want it to be 5/12, but in this quadrant, for the sign to be a negative, they both are going to be negative. So I have to go to the left 5 and down 12. This is really just like the other ones, saying we went to the point negative 5/12. Now we're going to connect to the origin, make a right angle. The theta is by the origin. Okay. So then it says find the values of the other trig functions. Okay. So we have to find r. Now it's just like the other problems. It is the square root of negative 5 squared plus 12 squared, which is the square root of 169 or 13. Now remember, your hypotenuse is always positive. The x and y might be negative, but the hypotenuse is always positive. Okay, so we know sine is y over r, cosine is x over r, tangent is y over x. We already know that, so let's put that in. Okay, now our sine is the y value opposite over hypotenuse, negative 12 over 13. Now remember, they said that our sine better be less than 0, negative. It is. Bam, that's great. Cosine is adjacent over hypotenuse, or x over r, or negative 5/13. So we have all those. Now let's write the reciprocals next to it. So we flip them over. So that's negative 13 over 12, negative 13 over 5. The negative traditionally should go in the front or on the top, and then negative 12 over 5. Perfect. So that is how you do those. So now let's take a look at the homework. For the homework, you're going to draw the points and the triangles on the XY axis. These are just like example 1. You are going to find the exact values of the 6 trig functions. I want exact values. If it's not a perfect square root, I don't care. Leave it square root of 2, square root of 7, whatever. Okay. And then this is like the second example. They've given you some hints about where the sign is, maybe positive and the cosine negative, or vice versa. So that is what you're going to use to draw the triangles here. But I do want a triangle drawn for each of those. So that is your 7.3a homework. Please work on that now. Thanks.